All right, the other day, we talked about solving linear equations. We talked about solving some real simple linear equations. We had things like 3x equals 12. How do you get the x all by itself?
Divide 3 by both sides.
Divide both sides by 3. All right, so we divide both sides by 3, and we get x is 4. Or we might have had something like x minus 5 equals minus 9. How did we get the x all by itself? Add 5. So we added 5 to both sides, and we ended up with negative 9 plus 5 is? Negative 4. All right, so what we're going to do today in section 4.4 is we're going to kind of put it all together, and we're going to have equations that are a little bit more complicated. For example, we might have something like 3x minus 2 equals 8. And I think we did ones like this the other day too. What would you do to get the x all by itself? Typically, we do the adding and subtracting first because we saw when we didn't do that the other day, we got lots of fractions that we didn't like. So typically, we would add first and then divide by 3. So x is 10/3. And we're going to leave our answer as 10/3. We're not going to write it as a decimal. Why not? It's a repeating decimal. It's one that goes on forever. We don't want to round it off. We like it just like that, 10/3. We're going to leave our answers as fractions. Okay. Well, what do I mean by ones that are a little bit more complicated? What if I have 5x plus 2 equals 3x minus 8? What's different about that equation?
X on both sides of the...
It has x's on both sides of the equal sign. What do you have to do when you have x's on both sides of the equal sign? Combine how?
Like terms.
How do I combine the like terms?
You would subtract. Yeah, you would subtract the 3 from 5.
Okay, very good. What you want to do is you want to rearrange. You want to get all the x's on one side and then all the numbers on the other side. So I agree with you completely. What I would do is I would put all the x's together by subtracting 3x on both sides. 5x minus 3x is 2x. And then we still have the plus 2 equals negative 8. If we get all the x's on the left-hand side, what are we going to do with all the numbers? Get them on the right-hand side. So how do you get all the numbers on the right-hand side?
Subtract 2.
Subtract 2. Perfect. 2x is negative 10. And then finally, divide by 2. X is negative 5. Questions on that one? Oops, can't see the answer there. Okay, what if it's even more complicated than that? What if we have 8 minus 2x minus 2 equals 3x plus x?
Did you combine like terms?
Okay, now, when we did the last problem, we called it combine like terms. What do you mean this time when you say combine like terms?
Like on that side of the equal sign, 2x plus x, would you think of 4x?
Absolutely. What you notice over here on the right-hand side is that you have x's here and you have x's again. So on the right-hand side, we have like terms. So we can go ahead and we can combine them together. 3x and x makes 4x. So on the right-hand side, I'm going to write that as 4x. How about on the left-hand side?
The 8 and negative 2.
I have like terms on the left-hand side too, don't I? I've got two numbers, 8 and negative 2. What do 8 and negative 2 make? 6. What's going to happen with that minus 2x?
Is it be added to the 4x?
Eventually it's going to be added to the 4x. For now, we're just going to keep it though, right? Minus 2x plus 6. So that's something you have to do. Sometimes you have to clean up each side. Sometimes each side has stuff on it. Each side has like terms, and you can combine them together. So now I think I heard the next step. The next step, somebody told me, add the 2x. Is it okay to put the x's on the right?
Sure.
Sure it is. Nothing wrong with that at all. This gives us 6 equals 6x. And finally, divide by 6. X is All right, I'm going to do the same problem again, but I'm going to do it wrong. And you're going to tell me what I did wrong. So there's the exact same problem. 8 minus 2x minus 2 equals 3x plus x. I'm going to do this. And I'm going to write 10 minus 2x equals 3x plus x. What did I do wrong? Didn't do what on the other side of the equal sign? That's right. I didn't do the same thing on both sides of the equal, did I? When I did plus 2 and plus 2 here, where are they? They're both on the same side. Is that legal? No, I can't do plus 2 on the left and plus 2 on the left again. Okay? But that's a very common mistake. That's something that I'll see a lot of people do. Okay? You can't do that. You can't do plus 2 on both sides of the left. If these are already both on the left, you just put them together. 8 minus 2 is 6. Okay, questions on that? All right, well, let's see, they got some fun ones here. How about 1 minus 3 times 5b minus 2 equals 4 minus 7b plus 3, and the 7b plus 3 is in parentheses. What do? You got to do the parentheses first. Basically, you got to clean up the left-hand side, and you have to clean up the right-hand side. So for just a minute here, let's forget about the right-hand side altogether, and we just look at the left-hand side. What would you do to clean up the left-hand side?
Multiply negative 3 by 5b and negative 2.
Multiply the negative 3 into the 5b minus 2. How come you don't do 1 minus 3 first and write that as minus 2?
You gotta get rid of the parentheses first. It's the order of operations, right?
Order of operations, what comes first? Multiply or subtract? Multiply comes first. And again, that's a common mistake. I'll see people write negative 2 right there. We should have 1 minus 15b
Plus 6.
plus 6. Excellent. Remember, you're running a minus 3 through, so minus times minus is a plus. That's easy to mix up too. Okay, is there anything else we can clean up there?
Combine 1 and 6.
Combine the 1 and the 6. 1 and 6 make?
7.
7. So the left-hand side, all cleaned up, is minus 15b plus 7. Then we got to do the same thing to the right-hand side. So we flip our folder over.
4 minus
4 minus
1b, or 7b.
7b minus 3. Excellent. So again, it's a distributive property there. You've got to distribute that minus through. Think of this. Math people are lazy. There's really a minus 1 right there, so we're really multiplying by minus 1. Again, is there anything I can clean up?
The 4 and 3.
4 minus 3 makes 1. So I'm going to write this as minus 7b plus 1. Okay, so there's what you need to do. Before you can start solving, you've got to clean up the left-hand side, clean up the right-hand side.
No. 4 minus negative 3.
Oh, don't get confused here. This minus is with the 7b.
Oh, right.
So it's just 4 minus 3. There's only one minus sign there with the 3.
Right.
After we clean up each side, what should I do next?
Would you subtract the 15b from, or the 7b from the 15b?
Okay, so what you're saying is I got to get the b's together. And I have a choice here. I could either add 7b to both sides, or I could add 15b to both sides. I can cancel out a b on either side. Sounds like you preferred the add 7b, so that's what we'll do. That's right, you get the same answer either way. It doesn't matter if you put the b on the left or the b on the right. Some people are very fanatic. Some people say the b's always have to go on the left. I've seen other people who are very fanatic and say, I always want to get positive answers. So some people would say, I want to add the 15b because negative 7 plus 15 will give me a positive number. Which way is the right way?
Either one, right?
Either one, they're both right. Okay. What's negative 15b plus 7b? Negative 8b plus 7 equals 1. Next thing to do, subtract 7. Get all the numbers on the other side. Minus 8b equals minus 6. Divide by negative 8. b is negative 6 over negative 8, which is, of course, 6 over 8. Two negatives make a positive. And I suppose we should reduce top and bottom by 2 and write it as 3/4.
Which section is this?
This is section 4.4.
When class is finished, I will go over those numbers.
Absolutely. Well, it'll be recorded and posted online, too. Okay. Other questions? All right, well, they make it worse than that. How can they make it worse than that?
From an exponent?
No, there will be no exponents.
Showing more letters?
Fractions?
Fractions, there you go. Now you're thinking. Fractions. All right, let's do a couple of fractions then.
Love fractions.
That's what I like to hear. Love the fractions. 5/4 plus 9/2 x equals 3/8 x minus 1/4. Love the fractions. All right. Well, a lot of students look at that and they freak out. They see lots of fractions. Looks scary.
It's the same thing, isn't it? Combined.
Except I have an idea to make my life a whole lot easier. What I do when I see an equation, and my equation has a whole bunch of fractions like this one does, I look for the common denominator. What's the common denominator? 8 would be the common denominator, right? What I'm going to do is I'm going to take every single piece and I'm going to multiply it by 8. Why does that help?
They all have the same denominator for combining purposes?
No, it's going to be even better. Look what happens when I multiply by 8. What can I do with an 8 and a 5/4?
Oh, cancel.
I can cancel. Cancels to a 2 and a 1. 2 times 5 is 10. First fraction gone. Plus, how about this one? What's 8 divided by 2? 4, but then I have the 4 times the 9. 4 times 9 is 36x. Second fraction gone. Equals. Next one. 3x minus 2. So why do I like to multiply everything by the common denominator? Makes the entire problem easier because it makes all of the fractions go away. All right. So when I have an equation and I see fractions, that's what I always do. I always multiply by the common denominator, and then I don't have to worry about fractions anymore. In my opinion, it makes my life a whole lot easier. Okay. Well, now that the fractions are gone, this looks a lot easier. What would you do? Subtract 3x. Okay. So that gives me 10 plus 33x equals negative 2. How do you move the 10 over? Subtract it. Thank you. 33x is negative 12. And finally I divide. X is negative 12 over 33. Can top and bottom be reduced?
Yes.
Yes, by 3's. So minus 4 over 11, I think would be my final answer. Questions on that? Okay, let's try another one of those. How about 4/3 x minus 2 equals 3x plus 5 halves. Again, I see an equation. My equation has fractions. What do?
Find a common denominator.
I find a common denominator. What's a common denominator?
6.
6 is the smallest one, so that's what I'm going to use. I'm going to multiply by 6. What do I multiply by 6?
Every 4/3.
Everything. When you multiply by 6, you have to multiply everything, even the ones that don't have fractions. Everything gets multiplied by 6. And when the ones that have the fractions, it's not a bad idea to put the 1 under them. That's an easy mistake to make. That's fine. The mistake I will see is I'll see people remember to multiply the fractions by 6, but they'll forget to multiply the other things. When you multiply by a number, you got to multiply everywhere, all the way across. How much is 6 times 4/3?
80?
8, because the 6 and the 3 reduce to give you a 2, so that's 8x. Minus 2 times 6. 12. Equals 18x. Plus 15, excellent, because the 6 and the 2 reduced to be a 3. All right, so once again, we're in good shape now, no more fractions. How do you want to combine things this time? All right, now there's an interesting thing. I heard add 12 to both sides. Is it okay to do the numbers first, or do you have to do the x's first?
It's okay.
It doesn't matter. So we'll do it backward this time. Usually I do the x's first, but there's no reason for that. You can do the numbers. So 8x equals 18x plus 27. So if you're putting the numbers on the right-hand side, where are you going to put where are you going to put the x's? On the left. So what do I have to do to get the x's on the left? Subtract 18x. So negative 10x equals 27. Divide by negative 10, x is 27 over negative 10. Now, here's something I will warn you about. If you type that into my lab, doing your homework online, I think it'll mark it wrong. And it's a really fussy thing. And the really fussy thing is, usually we don't put negative signs on bottom. So I think if you do that one in my lab, it's going to want you to write it as minus 27 over 10. Are those the same?
Yeah.
Yeah, because when you're dividing, one positive and one negative makes a negative. So I think my lab is fussy for that one, and I think it forces you to put the minus sign on top. Okay? If you forget about that and you do the work and it marks it wrong, let me know. I can go in and look at it and fix it. Change your score. Okay? But just be aware of that. I don't think it likes the minus signs down on bottom. Other questions? Okay. What about this equation? How about 2 times x plus 3 equals 2x plus 6? They're the same thing?
You have to distribute the 2 in the parentheses first.
Okay, so I distribute, I get 2x plus 6 equals 2x plus 6. When does 2x plus 6 equal 2x plus 6?
If x is 0,
Or if x is?
1,
Or if x is?
2,
Or?
any the same number.
Any number, right? Can I plug any number I want in for x? Yeah. So how many answers are there?
Infinite.
There are an infinite number of answers. That can happen sometimes. When that happens, we call this equation an identity. And that's simply a fancy word for an equation that is always true. So our answer is all real numbers.
Put the infinite symbol over your own.
Technically, yes.
Okay.
And I think in my lab, well, we got to talk about the other choice. What if I give you this equation? 2 times x plus 3 equals 2x plus 5. What can you tell me about that equation?
X equals -1.
I don't think so. Distribute 2x plus 6 equals 2x plus 5. What would you do next? Subtract 2x, get all the x's together. Well, there's stuff left. What's left on the left-hand side? 6 equals 5. When does 6 equal 5?
Never.
Never. So what does that tell you about that equation?
It's not true.
When is it not true?
Never.
Ever. It's never true. So what's the answer? Not unidentified. We would just write no solution. And when that happens, this is called a contradiction. Contradiction. So the directions you're going to see on MyLab, they're going to say solve the equation, or show that the answer is all real numbers, or show that the equation is a contradiction. And I think they have 3 boxes where you either type in a number, or you click on contradiction, or you click on all real numbers.
And the answer would be no solution?
The answer to this one would be no solution. That's correct.
And that's what you expect on our exams when you ask a problem like that. You want no solution or
Contradiction. Is the answer I would expect to see. You either write no solution or you write
and
contradiction.
then for the top it would be identity or all real numbers.
For the one on top, you would write identity or all real numbers. Correct. Other questions? Couple word problems in this section. It says Chicago taxis charge $2.25 plus $1.80 for each mile traveled. Find an equation of a linear model to describe this situation. Explain what your variables mean.
Pete, where are you?
Last page.
Oh, sorry.
There you go. Okay, so here's the deal. You go to hop in a taxi. They charge you $2.25 just for getting in and sitting down. So you get in, you sit down, you turn around and get right back out, you got to pay them $2.25. Then, after you sit in the cab, they start to drive, they charge you $1.80 for every mile. So we want to write an equation for that.
Y equals 1.8x plus 2.2.
Okay, so I hear a vote for y equals, say that again,
1.8x
1.8x
plus 2.25.
plus 2.25. Okay, then it says, explain what your variables mean. So what is x?
For miles.
X is the miles. And what's y?
Total.
Total what?
Dollar.
Total cost. Yeah, I would just put cost. Is that equation correct?
Yes.
Yes, why?
Because you
Because
know
money
that-
equals money.
Because money equals money. I like that answer.
Unit analysis.
Unit analysis. Cost, y would be in what units?
Dollars.
Dollars. What's the 1.8?
Dollars.
Dollars for each mile.
Per mile. Dollars over mile.
So that one's dollars over mile. And x is miles, so the miles cancel out. And the 225 is dollars. So I would agree, dollars equals dollars. How did you know that this 1.8 was your slope?
because it's constant.
Well,
Or
the,
wait, no, I'm sorry.
the 225 is constant
Yes,
too.
yes,
Because it says each mile, that's how I kind of remember it as my slope per each.
There's the big key. The big key is right here. When you see per mile or for each mile, any wording like that, that number is always your slope. Always, always, always. If a person paid $25.65 for a cab fare in Chicago, how far was the ride?
You would put 25
Close, not X. What's X? X is?
13.
X is miles, isn't it? That's why it's very important that you explain what your variables mean, so that you know which one to plug in for. If I'm giving you $25.65, that's got to be a Y number because it's a money. If I gave you 25 miles, then that would have to be a X number. That's why it's important back up here to write down what your variables mean, so you know what you're plugging in for. I wouldn't have used X and Y. I would have used C for cost, and I would have used M for miles, and then it even further helps me remember which letter is which. But there's nothing wrong with using X and Y. Okay, so anyway, solve. We want 25.65 equals 1.8x plus 2.25.
Subtract 2.25.
Subtract 2.25.
20.4. Divide 1.8.
So we get 23.40 equals 1.8x.
If we leave out the zeros, are you going to care?
I will not care if you leave out the zeros. I left it out on the 1.80, didn't I?
Yeah.
So I'm not being very consistent.
You would divide by the 1.8.
I would divide by the 1.8, and of course I'm going to use my calculator here. I get x is 13 miles. Questions on that one? All right, let's give number 7 a try. The total number of overnight visits to national parks was 13.7 million visits in 2011 and has since decreased by 0.21 million visits per year. Predict in which year there will be 12 million overnight visits. Well, problem 7 isn't broken down like problem 6 is, but I think you ought to do it the same way. First, you should come up with your equation.
3.7 minus 0.25.
So we want, you said 13.7 minus 0.21x, and what's that equal to?
That's equal to the amount it decreases.
Y? I'm going to call it V.
Oh,
I like V
yeah.
today.
Okay, never mind, I get it.
What's V? Why did I use V? V stands for visits. And what's T stand for? Or maybe we called it X. What does X? I would have used T. What does X stand for?
The total?
Not total.
How many years since 2011?
Years, right? X is, somewhere in here I saw a time 2011. And since 2011, so that's what we're calling X. So I would have used T for time, but X is years since 2011.
Is it wrong if you did it the other way around?
What do you mean the other way around?
I did 0.21x minus 13.7.
Yes, that would be wrong.
Cool.
You could write it as minus 0.21x plus 13.7.
But I thought x went first because of the slope.
Typically, the x would come first. So typically, I would go mx plus b. Why is it important here that the slope is the one that's negative?
This is decreasing.
Because it's decreasing. So the slope has to be the negative number. So you had switching the order was okay, but then you messed up your signs.
Right.
Yeah. So I would agree. Typically, I would have written it this way. And once again, how did you know that the 2.1 was your slope?
Per.
I saw 2.1 million per year. And again, on this one, if you wanted to do a unit analysis, you could. I promise you it's right, so we're good. How are we going to figure out when there were 12 million overnight visits?
Plug it in.
Plug it in for which letter?
Plug it in
12 for
for
V. Why V?
because that's visits.
visa visits.
V is visits. If I told you how many visits will there be in 12 years,
Then you would plug that in for X.
then you would plug it in for X. Okay, so again, it's important that you write this down so you know which letter is which. So you know when you go to plug a number in that you make sure you're plugging it in the right place. 12 million visits, that's a V number. 12 equals minus 0.21x plus 13.7. How to solve?
Get rid of 13.7.
So get rid of 13.7 by subtracting. Negative 1.7 equals negative 0.21x. Divide by negative 0.21. X is 8.1 years. So when would 8.1 years be? Sometime in 2019. Because we started in 2011, we're now 8 years later. So these last couple word problems, this is kind of a combination of all the stuff we've done over the last couple of weeks. Writing the equations, and now once we have the equations written, we're learning how to solve them. Questions?
So when you divide negative 0.21 by negative 1.7, you get 8.1?
That's what I was told. I didn't actually do it. I just took it on faith that
It was technically 8.095. That's rounded.
8.095, he rounded off to 8.1. I would have probably just rounded it off to 8 years. Closest one. But, okay? So I'm trusting that people are pushing the right buttons on their calculator. I get burned by that sometimes. Other questions?